This is Jacob's Algebra, Chapter 10, Lesson 3. This lesson is about factoring polynomials into prime factors. So some polynomials are actually prime. Those are polynomials that can't be written as the product of polynomials of lower degree. So if we have something like 64 minus 64x minus 16x squared. Okay, so when we're looking at 64x minus 16x squared, it's pretty easy to see that x is a common factor because we have an x in the 64x and we have an x in the 16x squared. So we can definitely say that x is a common factor. Now when we look at our coefficients, we have 64 and we have 16. Those are both multiples of 8, so we can pull out an 8. Now what we need to do to factor this expression is see what we have to multiply by 8x to get 64x minus 16x squared. Well, 8x times 8 will give us 64x, and 8x times negative 2x will give us 16x squared. Now, to see if we factored this as far as we can go, we check what's inside of these parentheses to see if there are any common terms. And we can see that there is a common term still. We have an 8 and we have a 2 for coefficients. And those both have a common term of 2, a common factor. So I can also pull out a 2. So we had 8x pulled out already. I'm also going to pull out a 2. When we pull a 2 out of 8 minus 2x, 2 times 4 will give us the 8, and 2 times negative x will give us the negative 2x. So now I need to write this out as one group. We have 16x times 4 minus x, and that is 64x minus 16x squared completely factored. Now another way that we could have done this is with our grid method. So let me draw our grid over here and draw my line right there. Okay, so with the grid method, we know that we need to have 64x here and negative 16x squared there. So what we need to do is see what is our greatest common factor. And again, we could have looked at this and said, oh, well, I can see 8x being a common factor. What do we have to multiply by 8x to get 64? Oh, well, that would be 8. What do we have to multiply by 8x to get negative 6x squared? That would be negative 2x. And then we'd look at that and we'd say, wait a minute, these are both even numbers. We can break that down more. So if we divide both of these by 2, dividing the 8 by 2, we end up with 4. Dividing the negative 2x by 2, we end up with a negative x. If we divide that factor by 2, then we have to multiply this factor by 2. So our 8 becomes a 16. So what we have is 16x times 4 minus x. So we get the same answer either way. I just wanted to show you the way. So if you do start to factor something out and then you realize that there is still a common factor in the terms that are left, you can still continue to factor. Okay, so let's look at our problems. So we're going to try number 4, part C. Number 4, part C says, use the distributive rule to find each of the following products. So what we have here is x cubed times x squared minus 2x. I'm going to show two ways to work this. One is just straight multiplying. We're going to take our x cubed and we're going to multiply it by each of the terms inside the parentheses. X cubed times x squared, that's x to the 5th. X cubed times negative 2x is negative 2x to the 4th. Okay, the other way that we can do this is with our grid method. So I'm going to draw my grid and put in my dividing line. Okay, so what we have is x cubed being multiplied by x squared minus 2x. So x cubed times x squared is x to the 5th. X cubed times negative 2x is negative 2x to the 4th. So you can see that we get the same answer. I just wanted to show you that you can work it out either way. I don't care which way you work these out. Part D is 4xy times x minus y plus 1. So I'm just going to multiply this out. 4xy times the first term, which is x, is 4x squared y. 4xy times negative y is negative 4x y squared. Notice this time we just have an x and our y is squared because we have a y times a y, but there's no x term over here, so we just have the one x that we started with. And now we multiply our 4xy by the 1 to get plus 4xy. Now you can work this out with a grid method. I'm not going to show it here. I don't care whether you work the first problem by just multiplying it out or by using the grid method. So this was number 4, which is just like number 12 that I assigned as homework. So the next one we're going to look at is number 5. Number 5 is just like number 13 that I assigned as homework. It says find the greatest common factor of the terms of the following polynomials. So for part A, we have 14x squared plus 4x. So when you need to find the greatest common factor of something that has coefficients and has variables, first look at your coefficients. So my coefficients are 14 and 4. What's the greatest common factor of 14 and 4? Well, they're both even numbers, so 2 would definitely work. When we look at 4, 4 is going to be 2 times 2. So we can get 1 2 out of 14. Can we get a second 2? When we divide 14 by 2, we get 7. We can't divide it by 2 again. So 2 is our greatest common factor of our coefficients. Now we need to look at our variables. We have x squared and we have x. So when you have variables in the term, you need to look at all your variables. And if you have a constant, you have to look at that one also. That would be like an x to the 0 if you just had a constant. So when you look at your variables, your common factor for the variables is going to be the lowest degree that you have. We have an x squared and an x to the first power, because when there's no power listed, it's first power. The lowest degree of those is a 1, so we write just an x. So 2x is all we have to write for this. It just says find the greatest common factor. Part B, we have 2x squared plus 3x plus 6. So first we're going to look at our coefficients. Our coefficients are 2, 3, and 6. Well, 2 and 6 have 2 in common. 3 and 6 have 3 in common. But there isn't any number that's in common with 2 and 3 and 6 except for 1. Now we need to look at our variables. We have x squared, we have x to the first power, and then we have just a constant 6, which is like x to the 0. So x to the 0. What is our lowest degree for the variables? 0. And x to the 0 is 1. Our greatest common factor for this one is just a 1. Oh, I said that was part B. That is actually part C. I'm sorry. Now we're going to do part D. Part D is 16x squared minus 40y squared. Again, we're going to look first at our coefficients. Our coefficients are 16 and 40. What's the greatest common factor? Well, 1 is a factor, obviously. 2 is a factor of both, because 2 times 8 is 16 and 2 times 20 is 40. 4 is a factor for both. 4 times 4 is 16. 4 times 10 is 40. 8 is a factor of both. 8 times 5 is 16. I'm sorry, 8 times 2 is 16. 8 times 5 is 40. 8 is going to be our greatest common factor for our coefficients. So we're going to write an 8. Now we look at our variables. We have an x squared and we have a y squared. Well, the lowest degree for x squared is actually going to be an x to the 0, because not every term has an x in it. Our lowest degree for our y's is going to be y to the 0, because not every term has a y in it. So our greatest common factor for 16x squared minus 40y squared is just an 8. And so that was number 5, which is just like number 13 in the homework. Now we're going to look at number 7. I'm sorry, number 6. I can't even count today. Number 6 says factor each of the following polynomials by factoring out the greatest common factor of its terms, and then illustrate each problem by means of the area of a rectangle. This, I think, is worded very confusingly. So for an example, we're going to work out part C, which is 3x cubed plus x squared. Okay, so our coefficients are 3 and an understood 1. Our greatest common factor between 3 and 1 is just a 1. So that's the greatest common factor of our coefficients. Now we look at our variables. Every term has a variable in it, so we can factor by our variable. We have an x cubed and we have an x squared. What's the lowest degree that we have? X squared. So our greatest common factor is going to be x squared. And I'm going to get rid of this 1 here and just leave it as x squared. Now, to factor out our greatest common factor, we need to draw parentheses here and say, what do we multiply x squared by to get 3x cubed plus x squared? Well, x squared times 3x will give us 3x cubed. And x squared times 1 will give us x squared. So x squared times 3x plus 1 is how we would work this problem. But then it says to illustrate the problem by means of the area of a rectangle. What that means is that we do a diagram. So we're going to draw our diagram and split it into 2 boxes. I don't know why I didn't draw them the same size. And we're going to put 3x cubed in one box and x squared in the other box. And what we're going to do is find what is our greatest common factor, and we're going to put that over here on the left side. That's x squared. What do we multiply by x squared to get 3x cubed? That's 3x. What do we multiply by x squared to get x squared? That's just a 1. So our answer for this, we need to write out x squared times 3x plus 1, and we need to draw this diagram. It takes both parts because it says to factor the polynomial by factoring out the greatest common factor and to illustrate it by means of the area of a rectangle. So we need both of these methods shown. So let me do part D now. Part D is 2x to the 4th plus 12x. And this time I'm going to start with the diagram. So let me draw my box and put in my grid line. And so now I'm going to write my terms in. We have 2x to the 4th and we have 12x. So what is our greatest common factor? Well, when we look at our coefficients, we have 2 and 12. The greatest common factor between 2 and 12 is just a 2. Then we look at our variables. We have an x to the 4th and an x. So we have an x in every term. Our lowest degree of x is just x to the 1st power. So 2x is going to be our common factor. What do we multiply by 2x to get 2x to the 4th? Well, that would be x cubed. What do we multiply by 2x to get 12x? That would be just a 6. So our answer would be 2x, which is our greatest common factor, times x cubed plus 6. To get full credit for this problem, you need to do both of these things. You need to draw the diagram and you need to write out what the polynomial is. Write it by factoring out the greatest common factor. Okay, so that was number 6, which is just like number 14 that I assigned for homework. We're going to start number 7, but we're not going to have time to finish it. Number 7 says factor each of the following polynomials by factoring out the greatest common factor of its terms. So it's just like number 6, only this time you don't have to do a diagram. So we're going to do just a couple examples. Part D is 2x plus 3y. So first we're going to look at our coefficients. We have 2 and 3. The greatest common factor for 2 and 3 is just 1. Now we look at our variables. We have an x in one term and we have a y in the other term. We do not have the same variable in every term, so our greatest common factor for this is just a 1. So to write this as, to factor this out, we would write 1 times 2x plus 3y. We wouldn't just write the 1. It didn't just ask for the greatest common factor. It said to factor it by pulling out the greatest common factor. So I